So example 4, hyperbolic cosine 4x minus 9. We can let u equals 4x minus 9. And then du equals 4 dx. So solve dx equals du over 4. And put it back. Plug the u back into the function, which is a hyperbolic cosine u times du over 4. And that is 1/4. Hyperbolic cosine is just the hyperbolic of sine u plus c. So the final answer is 1/4 hyperbolic of sine 4x minus 9 plus c. So next example, the hyperbolic of cosine x times the hyperbolic of sine x squared. These examples are very, very similar. It's pretty much like the trigonometry, functions, trigonometry substitutions. So we'll let u equals hyperbolic of sine x and du equals hyperbolic of cosine x dx. So you can solve the dx equals du over hyperbolic cosine x. So now you put it back, which is hyperbolic cosine x. This will be canceled, as we know that. U squared times du over hyperbolic cosine x. And that will give you 1/3 of u cubed plus c. And put the u back into the x, so 1/3 of hyperbolic of sine x cubed plus c. Alright, so in next example, we have the hyperbolic of tangent and hyperbolic of secant. Very similar like the secant tangent. Okay, so you let u equals 7 plus hyperbolic of tangent x. So du equals the derivative of hyperbolic of tangent is secant hyperbolic of secant square dx. And you solve dx, which equals du over hyperbolic of secant x squared. And that you put it back as hyperbolic of secant over u times du of hyperbolic of secant square, which is ln u plus c, and that gives you ln 7 plus hyperbolic of tangent x plus c. Okay, so in the next example, we're going to look at the inverse hyperbolic functions with 2 examples.